both. So we have CaOH2 goes to CaO, that's an A, plus H2O gas. So what's the enthalpy of calcium hydroxide?
-985.2.
Okay, units are kilojoules per mole. Okay, calcium oxide. Anybody? Brian?
Oh, yeah.
Number?
Oh, negative 634.9.
Kilojoule per mole. Water is in gas form?
Yeah.
Negative 241.8 kilojoules.
Ugh.
What?
It's a pair.
It's a bad handwriting.
Wait, is that
Air.
right?
Okay,
Well,
since these are all ones, is that right?
they're all zeros. No.
H2O gas,
No.
negative 241.8. Yep. So, since they're all 1 mole, we don't have to multiply them by anything. Take your products minus the reactants. So these are both negative because these are both negative. Otherwise you would just add them. I mean, we are adding them. Like plus, minus, right? So you do that and you find out that the answer is 108.5 kilojoules. Since this is positive, energy is leaving the system. Okay, so there was more energy here. It is now going out, so this is, I'm doing this wrong. More energy is going in because this has less energy, that has more energy. So energy is coming in. This is endothermic. So if it's positive, endo. If it's negative, exothermic. Thank you. It's all the seniors. All the seniors. Yes?
Why did you, so you see how you did like 98.5.0 for -6?
Yeah.
In parentheses, why did you do it like that?
Because this minus distributes to both. Because it's
Yeah.
products minus reactants.
Oh, so even if it's on the other side, it's reactant?
Thank you.
So the answer's
Good
gonna be
catch.
different?
No, that's the right answer. I looked in the book. So you have like 800, negative 800 plus 900. That's like 100. Yeah. Okay, next. Number 7. Some instant ice packs contain ammonium chloride, which dissolves to produce 2 ions in a reaction similar to that involving ammonium nitrate. So this was, neither of those were ammonium nitrate. Okay, so the ammonium ion, so ammonium is NH4 plus, has a delta H of negative 132.5 kilojoules per mole, and delta HF of chloride is negative 167.2 kilojoules per mole. Calculate the enthalpy of the solution. All right, so basically what we're saying is we have ammonium chloride, and it's breaking down to ammonium, chlorine, and ammonium. Okay, so this has negative 132.5 kilojoules per mole. This has negative 167.2 kilojoules per mole. So, can we figure out this guy? Sure. So, what we're going to do is we are going to do products minus reactants equals 0, because this thing is just breaking down. Break it down. So, we have 0 equals this minus x. So x equals that, which is, am I wrong? I'm wrong. You have to look up this guy. That guy. So what is the delta H of that? Go to the table. NH4CO. We have a negative 314.4. So if you want the solution, got your 314.4, and that should give you something. What is that going to give you? I'm really not feeling doing math today. It's a bad thing for a math teacher. There we go. So what does this tell us? For every mole of ammonium chloride, we release, or we absorb 14.7 kilojoules per mole of energy. So it's going to cool around it because we are absorbing that energy. Okay, so it gets cold. So now in number 8, they ask which one's better. And they give you that ammonium nitrate is 28.1 kilojoules per mole. So which one cools better? The one that absorbs less energy or the one that absorbs more energy? More, because then this will cool faster. So that's that. Homework, horrible. Always is, always will be. All right, let's move on. Bad news, we're going to lose some of our chemistry classes next week due to testing. But not many. So the suffering will be real.
Wait, but not yours.
I'll send out the email. You'll get a schedule, eventual. Yeah. But seniors, you will have a very full schedule. So for those of you thinking of ditching, be ill-advised. Esteban's not allowed to.
What?
Nice.
I'll be here.
What's the consequence for doing IAT?
It depends on how annoyed I am at you, but somewhere between Saturday school and getting kicked out of school.
Like just expelled.
Yeah. Like you're not welcome back here next year.
Except there are people who have done worse things, and they're
Wait,
still
okay.
living on campus.
So you're
Yeah, that's the thing about Calvary.
No, not necessarily, but if they make a habit of it.
Fired, and you'll still be welcome back.
I'm pretty sure.
It makes
You've said that more than once today.
No, Israel said it first.
I think it makes sense if somebody got
Alright. Moving
told
on.
to
So, talk about entropy. I don't know, I make up the consequences as I go. It's kind of fun. I mean, there's a handbook. It tells me what I'm supposed to do.
Corruption. I'm just kidding.
Please, enjoy a trip to the office. Perhaps, if Miss, here's a good one. If Miss Antrobus is there, then you can have a candy and come back. But if Miss Antrobus is not there, then you can just come back.
Can I call my mom real quick?
About corruption in the school?
Yeah.
Sure. If Miss Antrobus is there, you can have a candy and then call your mom. If she's not there, you just have to come back. But you can call.
Okay.
You can just come back. Alright, so we talked about entropy already. Now let's talk about the Gibbs free energy. Whoa. So we have 3 things that are important. Enthalpy. So we have enthalpy. Enthalpy is a measure of the lot. That's a bummer. Sounds like no chocolate for Buiza. We have good chocolate in there right now too. Like now is a good time to get some. No, like
The one we bought.
Talking Kit Kat.
you guys bought so much stuff and now it's just absorbed
Those
into
s'mores
the
I
school.
brought
still
those
have-
brownie things, and I gave them to Andres today.
We are doing s'mores.
Still have those cheese.
There.
No, we're not.
Hey, why would you give it?
I have all the stuff in my house. It's gotta
Because he
happen. We'll
asked
do
me
it
to
tomorrow.
take it. We're not doing it.
It's not gonna happen.
It's gonna happen.
I feel like
We're gonna
it's
make it
not
happen.
gonna happen.
Alright, I'm
Oh,
writing
Jesus.
this. You guys are really not in the mood to like
No.
absorb.
Hangies.
Oh, you
high
let
school
this one be in a mood?
It's cause okay, Gibbs free. Oh,
420.
so enthalpy is H. That was yesterday.
The sentence
Bobby.
in it with a wheeze.
We have entropy, which is G, no, S, and we have Gibbs free energy. And that's G. So, we often talk about these in changes of amounts.
Oh.
I know she's checking her stock profile, and she's chatting with students.
No, mine was on chemistry. I promise. It was.
And he's
He's on Google Classroom.
trying to
Yeah.
fix his car. Buying auto parts online.
Stock market is almost closed.
Yeah. So, Gibbs free energy actually tells you if a reaction is going to happen. So this is like a measure of how much heat is going in or how much heat is coming out. You have the entropy, which is just a measure of disorder. Generally, things tend toward disorder, so that's no big deal. But the Gibbs free energy, we talk about these in deltas because we want the change in that. It will tell you whether a reaction is going to tend one way or tend the other way. So, definition here is, this is a, where am I? There we go. Difference between the free energy of the reactant or products and reactants. So a delta G that is negative means that the reaction will happen spontaneously. And a delta G that is positive means that your reaction is probably not favorable or not going to happen. So, sure, they're sharp. Usually don't catch them. Just pull out a sharp.
Come on. Just pull it out.
See, they're sharp. They're sharp. Could inflict injury. All right.
Oh, that was awful.
That was horrible.
Okay.
Horrible.
So, how do we find delta G? Well, we find, again, the amount of free energy in each of the products and subtract the reactants. That tells us if it's going to happen or if it's not. So when we talk about spontaneous combustion, where stuff just wants to set on fire, right, that has to do with whether or not we have a positive or negative amount of free energy. So, let's go with this guy here. So go ahead and look up the Gibbs free energy or delta G for each of these.
An S or a 5.
S, because it's solid.
Not the Gibbs or the.
Yeah. Now the problem with Gibbs free energy is that it depends on both of these quantities. So actually, we need a delta H and delta S for each of these. In your notes, look at the little table. I think it's on page 352.
What is that before H2O? Is that a T?
I see we're being all critical of Elena's handwriting now.
Oh, I'm sorry. The H
Oh,
is
that was a plus. Yeah, what is
the H
that?
is the HF, right?
Is that an L?
Oh, that's an L?
It's a fish.
I thought that was an E.
Everyone's a critic.
We're just finding the Gibbs free one.
We're just trying to decipher your handwriting.
So go ahead and find delta H and find delta S.
Oh.
Delta S. Is that
352.
That's
That's the S1. Yeah. Ooh. All right. So what's HF of magnesium hydroxide?
Negative 924.5.
And since we have 1 mole, it's just going to be 1 kilojoule. What about magnesium oxide?
Negative 601.6.
We have 1 mole, so it's just that. Water, liquid, from the table. You have 2 what?
No. It's. Oh yeah, no, it is 3.
Okay, now find the S value for each of them. So S for magnesium hydroxide, S7. You got it, buddy.
It is negative 641.3.
That's right, 63.2.
No, sorry.
63.2 is correct. And that's joules per mole Kelvin. Okay. Magnesium oxide. Yeah. Joule per mole Kelvin. And water, liquid, Ryan?
Oh.
Grace? Liquid water, S.
Oh, 69 point.
It's too late. I called on someone else. It's over.
Wait, is it changing or?
Oh.
It's just the actual values.
Mr. Blunt, I'm just a little bit slow, so.
You know what? I'm sorry.
Grace?
69.9.
69 point. There's 2 waters because it's different state.
Yeah.
69.95. Okay, so here's what we're going to do. We're going to find the Gibbs free energy for this reaction, which is going to tell us did our free energy go up or down as a result of this. The equation for delta G is as follows. It is delta H minus T delta S. So I have to find delta H, which we've been doing this whole time. We have to include the temperature, which they give us in the problem, and then we have to do delta S. So what is delta H? It is the products minus reactants. So products, negative 601.6 minus 285.8 minus negative 924.5. So that's delta H minus, I'm going to do it,
No.
T, which is 298 Kelvin, delta S. What's delta S? Products minus reactants. Products minus, so products minus reactant. Okay, we have some issues. What is my first issue? It's on 2 boards. Second issue? Evo can't see, so anyone watching later will have no clue what we're talking about. That's cool. Next issue? Yeah,
There's a 2, so.
there's a 2.
Oh, wait.
Oh, wait.
I was thinking of moles.
Oh, okay. So let's address moles. I got rid of moles here. These are all in kilojoules. Why did I get rid of moles? Because it's 1 mole each. So for the same reason, I can get rid of moles here for the delta S because it's 1 mole each. Okay. Next issue.
Why is it so long? You had kilojoules and then you have joules per Kelvin.
Bingo. So I have kilojoules here, and I have joules here. So I'm going to have to convert either into joules here, or convert into kilojoules here, because I can't add 2 different units together.
Wait, I thought the T was the temperature, right?
T is temperature.
And it's in
Oh.
Kelvin.
Kelvin? Okay, that's really confusing because you have kilojoules and then Kelvin.
Yeah. But you'll notice that the Kelvin cancels here.
Yeah, but isn't that's kilojoules and that's,
Yeah. Oh, because there's K's everywhere?
yeah, that's
Yeah.
confusing.
That's a lowercase k.
That's also a lowercase k.
This isn't uppercase k.
Okay, that works.
Okay.
That works out much better.
K's are a little aggressive.
How do you know the temperature?
Because they gave it to us. Okay. Whoo! So, combine these numbers, what do you get? Numbers combining. Aren't those tickets sharp?
31.
Student council did a very good job.
Yeah, I stopped
Making
myself with
weapons.
it right now.
Positive.
Yeah.
I disagree.
The plus 924 related to there.
As soon as you see her.
I think that's
Yes.
wrong.
Be like,
The first half is 37.30.
Oh.
Oh, yeah.
Okay, so
Oh.
delta H is 37.1 kilojoules. Then we subtract the temperature times this number, which should be what?
what do you?
Like 33.75. Have I lost you yet?
Why did you,
Oh, it says error.
why did you on the S
I
part,
got-
why did you add some and then subtract?
Because it's products minus reactants.
Oh, okay.
Yep.
That
Okay.
makes sense.
So now we are going to multiply this out. Note, just like Emma said, you have to convert either all of them into kilojoules or all of them into joules. I am being lazy, so I will work in joules, which means I have to multiply this by what number?
Oh, well, you'll have to
How do you get from kilojoules to joules?
1,000.
1,000. Because there is 1,000 joules in 1 kilojoule. Right, if you have a kilometer, that's 1,000 meters, so it should get bigger. Okay, so if you multiply those out, what do you get? You're not calculating, you're passively like dozing off into sleep time. Huh? To calculate things?
No, to come to my mom about counseling. That was where.
Bye.
You wanna use the school for you?
No, you can just go and use your phone. It's prom.
Oh,
You found the soft spot. You can't get away with using your phone anywhere, but then.
I was trying to look.
Oh.
Mr. Belinda, you make a better corn like than a Oreo. Sure you go.
Go get a drink. Alright, so this number is positive, so what does it tell us? It tells us that this reaction is not going to happen unless extreme amounts of energy are plugged into this. Okay? Multiply by 1,000, that gives you joules. How do I get rid of the Kelvin? Because they're multiplied, so it cancels. Okay. So, this is not going to happen. Bonus question, when will it happen? Can I change the inherent energy in these, or the inherent heat in these compounds? No, we looked it up in a table, right? Can I change the relative disorder of these compounds? No, we looked it up in a table. What's the only thing we can change? In this equation right here. What's the only thing we can change?
Temperature.
We can change the temperature. So, by increasing the temperature, this gets more, stop.
Exothermic.
It gets more negative, right? Because the negative term gets bigger. And then there is some temperature at which the Gibbs free energy will equal 0. Above that temperature, it will be negative, and this reaction will happen. So sometimes you have to heat things up, in this case magnesium hydroxide, in order to get it to happen. So my question is, at what temperature is delta G equal to 0?
Do we do that?
Yep. So instead of putting 298 here, you're going to put what?
0?
Just T.
T. Set this equal to 0 and solve. Go ahead. Solve the equation. This is basic algebra. You got this.
But you said billions of people can't do algebra.
That's true. Fortunately,
How do
you know.
you want us to cancel Calvin or?
So our answer will be in Kelvin.
Yeah, so how do we?
You don't, because the joules will cancel.
Yeah.
Huh, that's big enough. You're not trying. I can tell you're not trying because you're not trying. You got this. So we're solving this equation